So we are dealing with the 11th problem in this series, and the problem is 3.11. The problem is stating a system consists of a thin charged wire ring of radius r and a very long uniformly charged thread oriented along the axis of the ring, with one of its ends coinciding with the center of the ring. The total charge of the ring is equal to q. The charge of the thread per unit length is equal to lambda. Then find the interaction force between the ring and the thread. So this is what the problem is stating us to find. So the first thing that we do is we try to understand it by drawing a necessary diagram of the system. So we have a ring, and this ring is along with a uniformly charged straight wire like this. So if we explain the charge distribution on the two surfaces, then I can say that some positive charge is on this ring, followed by some charge which is represented as lambda charge per unit length on this particular linear charge distribution, which extends up to infinity. So this is the system which the question is referring to. The total charge on the ring is equal to q, the radius of the ring being equal to capital R, and over here we have a uniformly charged wire which is having charge per unit length as lambda and extends from the center of the ring to the infinity. So over here we consider an elemental charge length dx, which is at a distance x from the center of the ring. So this length dx will hold the charge dq equals lambda dx. So this is the charge which this small element holds. And if we calculate the electric field at this point, which we have already calculated in the previous problems, which is equal to kqx upon x square plus r square to the power 3 by 2. So from these two deductions we can say that the force on this, and this is directed along the axis of the ring, E on the axis of the ring. So therefore the elemental force dF on this charge can be written as 1 upon 4 pi epsilon naught q lambda x dx upon x square plus r square to the power 3 by 2. And since this wire stretches from 0 to infinity, so we consider the length from 0 to infinity. If we integrate along the entire length of the wire, then we will get the final answer. Now to enable this integration, we are again considering one setup. We need to use substitution to solve this integration. So over here let us consider something like this. We have a radius r, we have this distance x, and over here we are considering a triangle like this. So this is the radius r, this is the distance x, and over here we consider this angle as theta. So if we consider this one as theta, then we can frame a substitution method to solve this integration. So over here I am writing tan theta equals x by r, and x can be written as r tan theta, and dx by d theta can be written as r sec square theta. So therefore dx can be written as r sec square theta d theta. So if I use this value of x and this value of dx in this above equation, so we get f equals integration 1 upon 4 pi epsilon naught q lambda, x can be written as r tan theta, dx can be written as r sec square theta d theta upon x square plus r square. So that is r square tan square theta plus r square to the power 3 by 2. And if we think in terms of angle, so if x is equal to 0, the value of theta is equal to 0, and as this x extends to infinity, the value will become equal to 90 degree, or we can write pi by 2. So if we solve this expression, we will get the value of force. So therefore force can be written as q lambda upon 4 pi epsilon naught r. So these are the terms which we can take common, and then we are left with integration of tan theta sec square theta upon sec cube theta d theta, extending from 0 to 90 degree, and then we get q lambda upon 4 pi epsilon naught r. So this value is equal to sin theta d theta from 0 to 90 degree, and hence on solving we obtain q lambda upon 4 pi epsilon naught r. So this is the final answer for this particular problem which we have discussed.